of our introductory lesson on the energy transition process with the title The 3 Pillars for 100% Energy Supply with Renewable Energy. And the second one will be on renewable overproduction. Let's see our consumption of the year 2010, at least of 6 months of the year 2010. And what we see is always those 5 days with a high consumption, that is the working days, and then the 2 days with a lower consumption, which is the weekends. And then it differs a bit according to the ambient temperature, but that pattern is quite constant. And when we look what was generated in 2010 on solar power, then we see that here in yellow. The wind power we see on green, and the renewably generated, the sum of those two, wind and sun, is now here this green pattern. We see it's quite chaotic, and we also see in the year 2010, definitely we never had the problem of producing more renewable power than we consume. But when we now shift that to the year 2050 and use the same consumption like in 2010, and we assume the same weather like in 2010, but producing or having so much wind parks and solar power stations that we have 100% renewable generation, then we have that pattern. Blue is still the consumption and the gray lines now will be our supply. And in some they are identical, that means we have a 100% renewable supply. Then we see automatically sometimes we have immense overproductions, and other times where we still have a few days or even many days where we produce less than we consume. And when we want to realize that by storage, that means we need to install both. One, in terms of power related resources, but also in terms of energy capacity related resources. It's an immense expenditure. And maybe it's not the best idea. So when we have the same pattern, but now we even produce 20% more renewable power than we need, it seems a bit strange to produce more than we need, especially with the old way of thinking. When we have nuclear and fossil resources, then it's stupid to buy fossil fuels, that we produce electricity and not use it. But that will be different when we have solar and wind, which does not have costs, that only has technology costs, but not having a primary energy costs. So with that 20% overproduction, we could say, now we don't need for every peak a storage device. We maybe can cut here the production that we still store in a way, less than 200 gigawatt. And that makes less energy storage necessary. And that is nothing else, you know, all that way of thinking. When you look in your city, all your parking meters, almost all your parking meters, are equipped with a solar and a battery systems, with renewable power generation and with an energy storage device. And when you see that system, that small panel that produces many times the power that is needed by that ticket vending machine. But it's a much more economic efficient system having a small energy storage device that only maybe can cover a few days when there is no sun, but not transferring all the power generated in summer to that time in winter when we have less solar power generation. So in that simple system of a parking meter, you already have the idea implemented. You producing more renewable power than you consume in order to make the storage small. That makes the overall system much more efficient. So the second pillar is definitely renewable overproduction, not only storage, overproduction. And again, theoretically we could solve all the challenge without storage, only with overproduction. That means we store even that much wind that in the calmest night it is sufficient to cover our needs, but for sure it's quite logical. It's not the efficient way to solve everything by overproduction. But pure theoretical thinking could say we don't need storage, we can produce or solve all the problem by overproduction. So that was a short presentation. The first two pillars are storage and overproduction. And now we go for the next video and look to pillar 3, and that will be grid extension. So see you later in the next system.